Hello guys, welcome to Coding. In this video, we are going to see the Leetcode problem number 36, valid Sudoku. Let's get into the problem. So the problem statement is determine if a 9 cross 9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. So these are the rules for the valid Sudoku. These are follows. So each row must contain digits from 1 to 9 without repetition. Each column must have 1 to 9 digits without repetition, and each 9 3 cross 3 sub boxes of the grid must have only digits from 1 to 9 without repetition. So these are the three rules. So we need to validate for all these rules for the given board. So yeah, let's get on to the problem definition. So first step is to define the problem. So the input is nothing but Sudoku board or size 9 cross 9. So output should be true or false based on whether it is valid Sudoku or not. So if it is valid, it will turn true, otherwise false. So validity of the board. So this is the output that we need to go. So the rules are as follows. Each row must have digits from 1 to 9 without repetition. The same goes for column. So each column should have digits from 1 to 9 without repetition. And each 3 cross 3 boxes should have digits from 1 to 9 without repetition. So these are the rules for a valid Sudoku, and there may be empty cells in the Sudoku. So they have also given that Sudoku board could be valid if there is no possibility for solving the Sudoku. Even such cases are allowed here. So even if the Sudoku is not able to be solvable, we can consider this as a valid if these three rules are met. So we need to validate only the filled cells. So we'll see what are the values that are present in the board. So the board will contain values from 1 to 9, and there will also be dot, that is a full stop, indicating an empty cell. So this is all about our problem. So how are we going to approach this problem? So second step is approach. So in order to approach this problem, we will check all the three conditions. So firstly we'll go to each row. So first row, second row, third row, and so on, and validate each row. So how we'll be validating it? So we can use a set to store each values. So each digits. So when we move to the first row, we'll add the values which are not equal to dot, which are empty cells. So except the dot, we'll add everything into the set. So if set contains, while we add any digit from each row, when the set already has the value to be added, that is the digit to be added, we'll return false, or else we'll continue to add the digit to the set. So we'll first step is to check row by row, and second step is to check by column by column. So second step is to check for each column. So for the first column, we'll have a set and keep on adding digits. When we find the digit is already added, we'll return false, or else we'll continue adding into the set. So we'll follow the first column. Next we'll go to second column. It goes on up to 9 columns. So this is the second step, first step, second step. So the third step is to check for each boxes. So boxes are nothing but a 3 cross 3, each 3 cross 3 matrix. So we will be checking for each boxes. So this is considered to be a one box. This is the second box. This is the third box. This is the fourth box. This is the fifth box. 6, 7, 8, 9. So there are totally 9 boxes. So we need to check for each boxes whether they contain unique digits from 1 to 9 or not. So empty sets can be ignored. So how are we going to check for this condition? So for this, what we will be doing is, firstly we'll locate the start. So for each boxes, the start are as follows. So we'll use another color. So this is a start. This is the start of the second box. This is the start of the third box. This is the start of fourth box. Fifth box start, sixth box start, seventh box start, eighth box start, and ninth box start. So firstly we'll go to each start values. So this is a start, we'll start. So there are totally 9 starts. So what we'll be doing is, we'll go to the start and check for 3 rows and 3 columns. So we'll be checking 3 rows and 3 columns from each what to say, for each boxes. So for initially when we are at here, they start, we'll start from each, we'll iterate over each row and also the each column. So same goes to second start. So when we consider the second start, we'll go to 3 rows and also the 3 columns. So we'll continue this, and finally we'll check every boxes by using the start. Well, firstly, the first step for checking the boxes is nothing but to locate the start points and check over 3 rows and 3 columns from the start. So this is the step in the checking, validating of each boxes. So how are we going to locate the starts? So I'll clear this out. So in order to locate each boxes, before that we'll index them separately. So this is a 0, 1, 2, 3, 4, 5, 6, 7, and 8. This is 0, 1. So these are nothing but the indexes of each row and each column. This is the columns. So yeah. So what are the starts? So first step is nothing but to locate the start, right? So these are the start values. So how are you going to locate them? So before that we'll find what are the starts. So starts are nothing but 0, 0, 0, 3, 0, 6, 1, sorry, 3, 0, 3, 3, 3, what is this? 3, 6. So this is 3, 6. So this is 6, 0, 6, 3. That is this start, and this start is 6, 6. So these are the starts. So firstly we'll start. We'll use the start. So how can we locate each start? We are going to use a for loop. So for int let's say I for row. So I equal to 0. So we are starting from this is a row and this is column, right? So we have rows from 0, 3 and 6. So you start from 0 and go till less than equal to 6 here, and I will be incremented each time by 3. So I plus equal to 3. So this is the outer loop for check going over each row. So for going over each column we have 0 to 6. So same rule applies here. So for int j equal to 0, so we are starting from 0 on each row, right? So 0 and j less than equal to 6. So 6 is the boundary condition. So we'll go over each column, and we can clearly see that we are incrementing j by this the column by 3. So 0, 3 and 6. So j plus 2 equal to 3. So we have successfully located each start. So we have reached start. So what are we going to do this here? So we'll create a set of integer. So let's say digit sorry, character, because they are told mention that our give the matrix, that is the board given to us, will be two-dimensional character array. So we'll create a set of character. We'll call this as visitor this, and we'll create that. And after that, what we'll be doing is we need to move over 3 rows and 3 columns from each start. So you'll again use a for loop. Let's have x will be starting from I, that is the row. X will be for a row. So when we consider this start 0 comma 0, we need to traverse over 3 rows and 3 columns, right? So I will be the x initially, and x less than I plus 3. Why we are using this? So when we start from any row, we'll go till 3 rows, right? So we are having I plus 3. So when we start from 0, we'll go have boundary till 3. So less than 3 will be the values of the first box. So we are having I plus 3 and I plus plus. Since we for each boxes we have only one increment of row, so I plus plus, sorry, it is x plus plus. So I is for outer loop, so x plus plus, and for each column, so we have successfully iterated over each rows of the current box. So we'll iterate over each column. So for each column we'll be using a variable y. So y will be j, and y less than j plus 3, j plus plus. So why we are using j plus 3? Since we start from the 0th column here, we'll go till 3 columns. So 1, 2, 3. So this will be the boundary condition. So less than 3 will be satisfying for us. So we are using j plus 3. So this applies not only for post box. So same logic applies for every boxes. So here we'll be adding and checking with respect to state. So we'll close the bracket. So that's all about this. So finally I'll simplify the approach. So first approach, that is the steps to be followed is to check over each row, column, column and boxes. So we need to check for each row, column and boxes. And in order to check the row column, the condition is easy, but for box there is slight modification in checking, I mean the validating. So for boxes, the first step is nothing but to locate the start points, locate the start of boxes, and the second step is nothing but uh, iterate or validate three rows and three columns from start. So these are the two steps. So I think you'll be a little bit clear about this approach. If you are not clear, don't worry, you'll be clear in the coding section. So let's move on to coding section. So firstly, we have three helper function calls. So it's nothing but return valid rows. We'll pass the board here, and valid columns board, and valid boxes of board. So we are going to write the helper function here. So valid rows of, we'll get a 2D array of characters, which is the board. So we'll get the board here, and how to check the rows. So we'll have a for loop. So I less than board dot length. So we're using I to locate each row, and we'll have a set of integer, let's say visitor. So let's have character, since the given board is containing only character array. So character visitor is nothing but new asset. So write it over each column. So it's nothing but 9. So this is also 9, right? Why are we using 9? We have mentioned that there will be size of 9 into 9 cross 9 Sudoku. So J plus plus. If board of I comma j, which is the, if current value is not filled, will continue, or else if visitor contains the current value already, will return false, or else we'll add current value, current cell to the set. So finally we return true. So when will they, we mean with this condition, when we have the valid rows for the given board. So if there is no valid validity, that is if the validity is wrong, we'll meet this condition, we'll return false, or else finally we'll return true. So we are going to write the helper function for valid columns. So here we'll be just copying the exact logic of rows, and we'll do slight modification. So valid columns, and for each, initially we have used I for rows and j for columns. We'll just swap those. So we'll use I for column, so 0 1 zeroth column, first column. So these are nothing but zeroth column, first column, second column, third column, fourth, 5 6 7 8. So for we are going to move over, use the I for columns and j for row. So we'll just swap those inside this ji j. So I have successfully written the uh, column validation, and we are going to move to the box validation. So private boolean valid boxes will have functions like is valid boxes of character array 4. The first step to be followed here is locate each starts, and the second step is nothing but check 3 rows and 3 column cells. So first step that which is to locate each start. So I less than equal to 6, I plus plus. For in j is equal to 0, j less than equal to 6, j plus plus. So here we will be creating a set. So it's a set of integer visitor. It's called as visitor is equal to new hash set. We'll iterate over each. Now we have successfully when we write these two for loops. We have successfully completed the first step, which is locate each start. So inside this for loop, inside this nested for loop, when we use value that is I comma j, we can get the starts of the each boxes. So for each boxes, we are going to get a new hash set and going to use variables x and y to iterate over 3 rows and 3 columns of the current box. So I is assigned to x and x less than I plus 3 x plus s. So as I have previously mentioned, I plus 3 is nothing but to go over 3 rows. So in y is equal to j and y is nothing but columns. So y less than I plus j plus 3 I plus plus. This is used for boundary case for 3 columns. So if board of I comma j visitor, so if it is an empty cell, we continue. Or else if visitor dot contains j will return false, or else we'll add current cell. So finally we return true. So yeah, we have returned successfully. So let's so before that I have made a mistake, that is as we have discussed in the approach. So we need to move over increment by 3. So why we are incrementing it by 3? So since starts move 3 places, so we are incrementing it by 3. So we'll correct this. I plus equal to 3, j plus equal to 3. So let's check this out. So 49, I remember 49. So let's check this out. Yeah, I have made a mistake in function naming. This valid, this valid, and this valid. So line number 49. So this is a set of characters. Since our board has only characters, we are using a character array. Let's check this out. That's I got a mistake. So what mistake I have done here is nothing but I used I and j values. It should be x and y. So So let's check this up. Yeah, it's working fine. Let's submit it up. Accepted. And yeah, the time complexity of his approaches. The time complexity is nothing but O of m into n, and the space complexity. So m is nothing but number of rows and n is nothing but number of columns. Since we have only 9 into 9, we can consider this as a constant. So big of 1, and the space complexity is nothing but big of n, which is big of 9, since they have mentioned that 9 into 9. So the space complexity is also big of 1, and approach for this problem is nothing but matrix manipulations. So yeah, and also hashing. So is there any way to optimize this approach? And the answer is yes. So how can we do this? It's nothing but we'll be using a visitor array instead of using the set. Since we can reduce the bucketing time. So for each time, so we'll firstly create a character array. Sorry, visitor array, which is boolean array of visitor. We new boolean of name. So here we'll just fill visitor by false. So we'll fill false to every cells in the visitor, and for checking validity, we'll check whether visitor of current value, which is board of I comma j current cell, and minus 49. So why we are reducing minus 49? So it's because consider the number 1. So we are creating an array of 10 values, right? So 9 values: 0 1 2 3 4 5 6 7 8. Yeah, so the cell number 0 is used to represent the number 1. 2 will the 1 will represent the value 2. So it goes on till the value, that is the cell number, cell indexed 8 will represent the number 9. So initially we'll fill false to every values, and when we subtract the ASCII value of a digit by 49, it will help us to determine the position of values in the array. So this array. So if this value is true, it will indicate that you already added this value. So we'll return false, or else we'll just mark the value as true. So mark the current digit presence as true. So we'll use the same in below functions, and we need to use these two. So and filling the values. So it's done here and here. So let's check this up. So array index found line number 33. So minus 49. So mode of I and j is so let's print and see values dot. So if we meet dot, we are continuing, but I don't know why it's coming till here. So yeah, we have done a mistake here. So it's nothing but board of j and j. Since we have swapped the value of row and column in column, so these two must be inversed, right? So we are using ji instead of ij in row checks. So let's see this up. So what is the mistake here? Is valid columns. Um, it's valid row. So sorry. Here too, our condition must change to x and y. Let's click this up. Or let's submit it up. Accepted. So that's all guys. That's all of this video. Thanks for watching this video and have a great day.